So we're going to discuss how to solve radical equations now. And we've talked about all the operations in the previous video. In the video before that, we sort of talked about what a radical was and how to convert from mixed to entire and entire to mixed. So hopefully, having practiced those things, this will become pretty easy. So in order to solve a radical equation, you first of all have to understand what a radical equation is. When you have a radical equation, essentially what you have is an equation, so something equals something, but it has a radical in it. And we're going to talk about radical equations with one radical first. So there's one radical in it. So here's an example, okay? 5 plus the square root of 2x minus 1 equals 12. So it's an equation because it's something equals something, and it's a radical equation because it has this radical in it right here. Okay, so that's how we know it's a radical equation. So what are we going to do in order to solve this? Well, in order to solve it, what we have to do is get rid of the radical. So what we do is we, first of all, isolate the radical. So we move everything else to the other side of the equation. So we're going to do that first. Okay, so we're going to isolate the radical. We're going to go 12 minus 5 is 7. Okay, that's what we're doing first. So if you want to write in over top of this, minus 5 and minus 5, that might help you just sort of see what we're doing, but we're subtracting 5 from both sides to isolate the radical. Isolate meaning it's on the side by itself. Then the second step is to square both sides. Okay, now it may not be square. If it's a cube root, then you're going to cube both sides. If it's a fourth root, you're going to take the fourth power of both sides. So that's why I said, or whichever power you need to get rid of the type of radical that you have. So that's the next step. So let's do that. So we're going to square both sides. So we square this side, we get 2x minus 1 because the square root goes away. And we square 7 and get 49. And then the third step is just to solve for the unknown, to solve for x. So I'm going to do that next. So I'm going to go, well, that means that 2x is equal to 50. I just add 1 on both sides here. And then that means x is 25. Okay? So we get our answer. We get x is equal to 25. So then the last part says verify your solution. And you might say, well, what do you mean? If I solved it, then I should be right. What happens is because we're squaring both sides, we may end up with an answer that is going to give us a negative or something like that. It's not going to happen with one radical, but it may happen with more than one. So we always want to just check our answer. And to check our answer, essentially what we do is we plug it back into the original question and see if it works. Okay, so we plug in 25 over here. And we get 2 times 25 is 50, minus 1 is 49, the square root of 49 is 7, and 5 plus 7 is 12. And we say that's the same as the right hand. So the left-hand side equals the right-hand side. QED, meaning we proved it. It works. Okay? So those are the steps we're going to follow. So here's another example. We have x plus the square root of x plus 3 equals 3. So we want to isolate the radical. So what do? We move the 3 to the other side. Okay? So we get minus x plus 3. Then we square both sides. So if we square this side, we get x plus 3. This side gives us x squared minus 6x plus 9. Then we bring everything to one side because this actually now is a quadratic. So it's a little bit different than the previous one because the previous one was linear. So we bring everything to one side. So that's going to give us x squared minus 7x plus 6. Then we solve that. Now that factors nicely as x minus 1 and x minus 6. And then we get two answers. X is either equal to 1 or x is equal to 6. And then we go verify our solution. So the verification is right here. We check the left-hand side. We put in 1 first. 1 plus the square root of 1 plus 3 gives me 1 plus the square root of 4, which is 3. So that works. And the same thing here. We plug in 6. We get 6 plus the square root of 6 plus 3. 6 plus 3 is 9. The square root of 9 is 3. 6 plus 3 is 9, not 3. So this one doesn't actually work. So it's called it's called an extraneous root. All right, what is known as an extraneous root is what I was trying to say. And basically, why it happens is because when we square both sides, we're negating the effect of a negative. So this really should be 6 minus 3, right? That's what we would expect, and that would give us 3. But it doesn't work in the original question. It works when we square it, okay? Because what's 3 squared? Well, it's 9, and this side is 9. So it works when we square it, if you kind of think about it that way. the x value would work if we squared the x value, but it doesn't work when we don't because of a negative sign, essentially. So when we square these, we get rid of any possibility of a plus or minus, because whether you square a positive or a negative, you're still going to get a positive value at the end, right? When you square a positive, it's positive. When you square a negative, it's positive. So that's why we end up with what are called extraneous roots. It doesn't happen all the time, but it does happen enough that you need to check all the time. Okay, so it's a pretty simple procedure in terms of solving, but it is important that you check your answer to make sure that anything that you have is actually an answer and is not extraneous root. So here's another example. We have the cube root of x minus 2 plus 5 equals 7. So first step, isolate the radical. So we do that first by subtracting 5. And then here, instead of squaring both sides, we're going to cube both sides because it's the cube root. So we cube both sides, and we get x minus 2 is equal to 8. And that means that x is equal to 10. And then we verify that by putting 10 back in here. So we go 10 minus 2, that's 8. The cube root of 8 is 2, and 2 plus 5 is 7. That equals my right-hand side. So I know I'm right. Okay, so we isolate the radical, we square or cube or whatever the radical, whatever the index is, we use that as the power. And then we solve, and then we check our solution to make sure it works. Okay, so here's another example. Okay, what are the restrictions, this one says, of n? If the equation n minus the square root of 5 minus n is equal to minus 7 involves real numbers. So the restrictions are going to come from here. You remember in a previous video we talked about that, but you can't take the square root of a negative. So we're going to say, well, that means 5 minus n has to be greater than or equal to 0. Because if it's not, then we're going to take the square root of a negative number. And we can't take the square root of a negative number because anything squared is positive, whether it's a positive or a negative number. Okay, so we say n has to be less than or equal to 5. Then it says solve the equation. So now to solve the equation, the first thing we're going to do is we want to get the radical isolated. So we're going to bring the n plus 7. You notice we switched it. I brought the 7 this way and the minus that way to make it positive. So it says y in this case is the radical isolated on the right side. The reason we're doing that is because we want the radical to be positive, and it's negative here. Then I square both sides. So that means n plus 7 squared, and then this squared. So I get 5 minus n on the right-hand side, and n plus 7 squared is n squared plus 14n plus 49. It's a perfect square. You would have done it first semester. So then we bring everything over to one side. So if I bring the n over, I'm going to get 5n and then 44. So I have 15, not 5. But n squared plus 15n plus 44 equals 0. And I say, well, I can't actually factor that very easily, I don't think. Maybe you can. So we say, can I factor 44 and 15? Well, 4 and 11. Okay, yeah, I can factor it then. Perfect. So I do. I get 4 and 11. So then I take those and I solve them. And I get minus 11 minus 4. Now, often when you have a radical, that equation that results in a quadratic, it's going to be nice. It's going to factor. However, if it doesn't factor, or you don't recognize that it does right away, you can use what's called the quadratic formula. And you guys know this. You've done the quadratic formula. And either way, when you do the quadratic formula or you factor, you end up with two answers. You end up with minus 11 or minus 4. So we get to here and we want to check our answer. So we check n equals minus 4. We go n minus the square root of 5 minus 4. That gives me minus 4 minus the square root of 9. Square root of 9 is 3. So we get minus 4 minus 3, and that gives me minus 7. So we say that one works. Then we try minus 11. So we go minus 11 minus the square root of 5 plus 11. That's the square root of 16. So we get minus 11 minus 4, and that gives me minus 15. And the right-hand side is minus 7. Again, you'll notice that if this was plus 4, right, minus 11 plus 4, it would work. It would give you minus 7, but it's not. Okay, so we say that one doesn't work. So the only solution then, the only actual answer is n equals minus 4. That's the only one that actually works. The other one is extraneous. So that's the idea of solving radical equations with one radical. Okay? So there's a number of examples here, a number of questions for you to do. And we've done enough examples, I think, that you can probably solve these without too much trouble. But then the question becomes, what happens if I have two radicals? Okay, so what happens if I have two? So here's an example. I know this is not easy to see, but I have the square root of x plus the square root of x plus 21 equals 7. So what you have to do really is you have to follow the same sort of procedure, but you have to decide which one you're going to isolate. So you isolate one of the radicals. Doesn't matter which one. So in this case, I chose to isolate the square root. Well, I didn't choose it. Whoever wrote this textbook did, but we'll pretend it was me. Okay. I'm going to isolate the square root of x plus 21, which means I'm going to bring this square root of x to the other side of the equation. And then I'm going to square both sides, just like I did before. So this becomes x plus 21. This becomes 7 squared, which is 49, minus 14 root x plus x. Okay, now you'll notice what happens is I have a radical that pops out. But now I only have one. So I had two. Now I only have one. So I'm going to repeat the procedure. I'm going to put this by itself now, okay, which means I'm going to bring the 21 over, and I'm going to bring this x over, and I'm going to bring that way. So it becomes 14 root x equals 49, just so you can say, where did this 28 come from? It's 49 minus 21, and then we have a plus x already here, and we go minus x from the other side. So those canceled, and 49 minus 21 is 28, okay? And then we can divide this by 14. So it's just easier to do that before we square, because otherwise we have to square 14 and square 28, and those are fairly big numbers. So we just divide, we get the square root of x is equal to 2, and then we square both sides, and we get x is equal to 4. And then we check our answer to make sure that it works. When we get one answer, generally, we can be fairly confident that it's going to work, but it doesn't always. It's possible that there is no solution. But if you look at this, it does work. It gives us 7. Which is what we said it should, so we're good. So we have an answer, and the answer is x equals 4. So essentially, when you have two radicals, you do the same thing that you did with one. You just keep squaring both sides and then isolating the radical until all of the radicals are gone. So you basically have to repeat step 1 and 2 twice. Or actually, you have to repeat it once. You have to do it twice. This only works, though, the squaring both sides thing only works with square roots. Okay, because when you get into two different cube roots and you're trying to get rid of the cube, you have to cube both sides, and that doesn't always give us nice numbers. So you're going to stick with square roots for these. Okay, but here's another example, and we'll just walk through this one as well. So we have two radicals. The first step is to isolate one of them. It doesn't matter which one you isolate. So in this case, we isolate the square root of 3x plus 1. So we have on the other side then the square root of x minus 1 plus 2. Then we square both sides. So to square them, we get 3x plus 1 over here. Here, we get this squared, so that's the x minus 1, plus 2 times square root of x minus 1. That's where the 4 comes from, and then plus the last term squared. We're using the perfect square formula. Because you might be wondering, where is this coming from? What we're doing is we're using this, a squared minus 2ab plus b squared, or if it's plus, which is here, then it's plus. So it's plus or minus, depending on which one it is. So we're squaring the square root of x minus 1. That's giving us that x minus 1. Then we're taking 2 times the square root of x minus 1 times b, which is also 2. So that's where that 4 came from. It's 2 times the square root of x minus 1. And then it's plus b squared, and b is 2. So that's where the 4 comes from. Then we have to isolate that radical. So we're going to bring the x over, 3x minus x gives me 2x. And then I have 1 plus 1 is 2. And then minus 4. So that's where I get the minus 2 from. So again, if you want to write out what we did there, it's 3x minus x plus 1 and then minus 4 plus 1. Okay, because that 1 came over, that minus 1 came over, and that 4 came over. And that's where we're getting that 2x minus 2. It equals 4. You can divide both of those by 2 if you want to, or you can just square right away. It's up to you. So if you square both sides, you end up with this. Okay, which is just 2x minus 2 squared is first term squared. So you get 4x squared. Then you multiply them together. You get 4x minus 4x. Then you double that, right? The 2ab. So it's minus 8x, and then you square the minus 2 to get 4. Over here you have 16 times x minus 1. Then you divide everything by 4 if you want to, or you can multiply the 16x in, sorry, the 16 in first, which is what they've chosen to do here, and then bring everything to one side, then divide by 4. It really doesn't matter what you do when in terms of dividing by 4. But if you divide this by 4, you get x squared minus 6x plus 5. And that's where they're getting this x minus 1 times x minus 5. So you get two answers. X is equal to 1 and x is equal to 5. And then you just go back and check them to make sure that they work. So you go back up here and you plug in 1. And you can see the check there. You just work your way down. And then you plug in 5. Okay, and in this case, they actually both work. So we have no extraneous roots. We have two that actually work. Okay, which is great. So you just have to check each time. And again, here are some more questions for you to try. There's a whole bunch of them here. I'll leave it up to your teachers what they assign to you. If you're doing this, I would suggest, if you're doing this kind of on your own, I would suggest just picking a couple from each one. These ones get a little weird because they have denominators, so you just have to multiply up first. It's cross multiply is sort of the freehand way of doing it. I don't like the term cross multiply. Really what you're doing is getting a common denominator and then the numerator is equal, but you'd have to sort of do a little bit of work before you get to solve this. So what I'm saying is you'd have the square root of x plus 2 is equal to 2 times the square root of x minus 2. Okay, and then you would solve it using your equation. Again, same thing here. You'd multiply that and that up. So that's how you deal with those. And then down here, you've got your two radicals along the way as well. Some of them have more than one. If you look at, there are more than two. If you look at this one, for example, you've got 10 over root x is equal to this. What you want to do is multiply everything here by root x and then see what happens. Same thing here. You want to isolate one of the radicals. So you're going to bring that 2 over and then multiply up with the square root of x minus 3. So there's lots of different ways to do that. I won't go any further than that, but I'd like you to try those at your leisure. And if you have questions, please reach out.